Good afternoon friends and welcome again to another session of Parijat sir classes. एक बार आपका फिर से स्वागत है to another class of Parijat sir classes. जैसा कि आप जानते हैं, what I am doing is I am now making the sessions for certain important topics. जैसे प्रीवियसली ऑलरेडी रिलेशन फंक्शंस के कुछ टॉपिक्स हमने अपलोड किए हैं, डिफरेंशिएशन के कुछ टॉपिक्स अपलोड किए हैं. सो टुडेज अनदर इम्पॉर्टेंट वेरी टॉपिक ऑफ क्लास 12 CBSE, जैसा कि आप जानते हैं, और ISC. इट इज़ द फंक्शंस टॉपिक विच इज़ वेरी वेरी वन ऑफ द मोस्ट इम्पॉर्टेंट टॉपिक्स फॉर CBSE और ISC. सो 1 minute. There's some problem. Okay, so now what we will be doing is that today we will be discussing one important topic, that is functions, which is a very very important topic for CBSE. तो my suggestion is please आप मेरे क्लासेस को फॉलो करते रहिए, पूरे सेशन को देखिए. फंक्शन एक बहुत ही इम्पॉर्टेंट टॉपिक है. इट्स अ वेरी वेरी इंपॉर्टेंट टॉपिक फॉर द बोर्ड एग्जामिनेशंस. हर साल इसमें से क्वेश्चंस आता है. सो आई वुड सजेस्ट प्लीज़ इस वीडियो को आप फुल देखिए. प्लीज़ वॉच द फुल वीडियो. प्लीज़ वॉच द फुल वीडियो टू गेट द फुल कॉन्सेप्ट ऑफ दिस फंक्शंस टॉपिक. राइट, वीडियो को देखते रहिए. प्लीज़ कीप एंजॉइंग द वीडियो एंड प्लीज़ try to note down the things what is being discussed in this session, and importantly is that आप मेरे साथ न्यूमेरिकल्स को प्रैक्टिस करते रहिए. पॉज करके वीडियो को you please practice the numericals along with me. Okay, so this is Parijat sir classes. You are watching Parijat sir classes and I would request you please लाइक शेयर एंड सब्सक्राइब ज़रूर कर दीजिए. लाइक शेयर एंड सब्सक्राइब आप ज़रूर कर दीजिए मेरे चैनल को, सो दैट आई कैन मेक मोर एंड मोर सॉर्ट ऑफ दीज ओके चैप्टर्स वन बाय वन. मैं बनाता रहूँ आपके लिए एंड ट्राई टू मेक इट एज ईजी एज पॉसिबल. चलिए विदाउट वेस्टिंग टाइम लेट्स मूव ऑन टू व्हाट इज फंक्शंस. तो सबसे पहले देखिए वी विल डिस्कस अबाउट द फंक्शंस. फंक्शंस मेनली जो टाइप्स के फंक्शंस होंगे वो मैं आपसे पहले डिस्कस करूंगा. फर्स्ट ऑफ ऑल वी विल बी डीलिंग विद 1-to-1 फंक्शन. 1-to-1 फंक्शन, इसको हम लोग क्या बोलेंगे? 1-to-1 फंक्शन, एंड वी विल बी कॉलिंग इट एज इंजेक्शन. 1-to-1 फंक्शन को क्या बोलेंगे? इंजेक्शन बोलेंगे. नाउ व्हाट इज 1-to-1 फंक्शन? सपोज देयर इज अ फंक्शन जिसके x वैल्यूज को आप चूज करेंगे फ्रॉम A एंड जिसके y वैल्यूज आएंगे B. जिसके x वैल्यूज को आप चूज करेंगे A फ्रॉम द सेट A एंड जिसके y वैल्यूज विल कम फ्रॉम द सेट B. ओके, तो व्हाट इज अ 1-to-1 फंक्शन? व्हाट इज अ 1-to-1 फंक्शन और इंजेक्शन? व्हाट इज दैट? सो 1-to-1 फंक्शन होगा, सपोज यू हैव चूजन टू वैल्यूज. 1-to-1 फंक्शन क्या होगा? क्या सपोज यू हैव चूजन वैल्यूज फ्रॉम द सेट A. सपोज दीज आर द वैल्यूज यू हैव. दिस इज इट कंटेन्स A, B, C, D और एलिमेंट्स हैं, एंड दिस इज द सेट B. इट हैज गॉट सपोज E, F, G, H ऐसे और भी हैं. Suppose you choose two different elements. देखिए, two different elements from set A. You choose two different elements from the set A. Okay, and then you find that इसके solutions आ रहे हैं. A is having only one solution, B is having one solution, C is having one solution, and D is having one solution. So if every element of A has only one solution, for every element of A which is having only one solution, we call it a 1-to-1 function. We will call it as a 1-to-1 function. ठीक है, मैं आपको यहाँ पे समझा देता हूँ and please try to understand how do we call it. Suppose we choose the elements from this set A. Suppose we choose elements from the set which contains 1, 2, 3, 4, and suppose B is a set which contains these elements. तो हमको फंक्शन कहाँ से कहाँ दिखाना है, फ्रॉम ए, बाई चूजिंग एलिमेंट्स फ्रॉम ए एंड it will be related to b. Suppose the function is given as fx equal to x plus 2, fx equal to x plus 2. ठीक है, तो what we will do, we will choose x from the set A, we will choose x from the set A. तो देखिए, when I choose x as 1, when I choose x as 1, then how much, and put it in this equation, तो मुझे क्या मिला, 3, मुझे क्या मिला, 3. So when I choose x as 1, तो मैं दिखा रहा हूँ आपको, when I choose x as 1, so what did I get? I got 3. When I choose x as 2, what did I get? I get 4. When I choose x as 3, what did I get? I get 5. And when I choose x as 4, what did I get? I get 6. तो देखिए, every element of A has a different solution. एक solution आ रहा है. If I choose 1, I'm getting 3. If I choose 2, I'm getting 4. If I choose 3, I'm getting 5. If I choose 4, I'm getting 6. That means every element of A has a different image in B. Now, means each element of A set का एक ही आंसर आ रहा है, दो आंसर नहीं आ रहा है. Each element of the set A has only one answer. Like 1, when I choose 1, मुझे 3 मिल रहा है. When I choose 2, मुझे 4 मिल रहा है. When I choose 3, I got 5. When I choose 4, I got 6. तो देखिए, every element of A is having only one solution. That is why it is a 1-to-1 function, and this is called injection. 1-to-1 function is called injection. Okay. So what is the logarithm to solve this? What is the algorithm? How will you solve this? ये मेथड देख लीजिए. फर्स्ट यू विल चूज एनी टू वैल्यूज x and y from the set A. Choose any two values x and y. Now make fx equal to fy. और जो फंक्शंस दिए गए हैं उनको इक्वल करके सॉल्व द इक्वेशन. इफ fx is equal to fy and you get x equal to y, अगर fx और fy सेम आ जाए आफ्टर पुटिंग x and y, and you get x equal to y on solving, तो remember a function from A to B is a 1-to-1 or injection, else not. तो क्या आना पड़ेगा, fx is equal to fy आना पड़ेगा, and x should come equal to y. ये आ जाएगा. So it is a 1-to-1 function. Clear? So let us see with more examples. Suppose I take this. Check whether the following function is 1-to-1. The first one, let us take. See, they are telling कि the function, first function we will take real to real. That means choose your x from the real set and get your y from the real set. ये इसका मीनिंग है. Okay, so what is the function given? Function is given fx is equal to x cube plus 2. Okay, so I told you first write fx is equal to fy. So what is fx? X cube plus 2. What is fy? Y cube plus 2. So 2 cut. So x cube is equal to y cube. Cube cuts. That means x is equal to y. तो देखिए fx और equal to fy करके we got x equal to y. That means it is a 1-to-1 function. It's a 1-to-1 function. Clear? Now let's see the next part. They are telling the function is z to z. That means choose your x from the integer set and your y should be from the integer set. चलिए, तो let us now take fx is equal to fy. So what is fx? x square plus 1. What is fy? Y square plus 1. So now x square is equal to y square. तो हम इसको क्या लिख सकते हैं? x square is equal to plus minus y square. That means x is equal to plus y or minus y. That means for every x there are two values coming, either plus y or minus y. Single value नहीं आ रहा है, single value नहीं आ रहा है. That means we are not getting x equal to y. ये तो नहीं आ रहा है. This is not coming. So it is not a one-to-one function. It is not a one-to-one function. ये नहीं है. Clear? Next, let us see another one. Many-to-one function. What is many-to-one? Suppose you choose a function from a to b and you choose two values x and y, which is from the set A. You will choose what? X and y, you will choose two different values. And if you can show, you will choose two different values. X is not coming equal to y, but fx is coming equal to fy. Means x will not come equal to y, x will not come equal to y, but fx will come equal to fy. So then it is a many-to-one function. That means simple सा reason मैं आपको बता देता हूँ. X can have more than one value of y. X can have more than one value of y. The same x can have more than one value. That is why many-to-one function. 1 minute. Here, if I just take two values of x and they have the same solution, that means it is many-to-one function. Correct? So let us see with the help of an example. Example से देख लेते हैं. So we have to choose your x from this part and the y will come from this part. चलिए, let's start. The function is given, choose x from this set and y should be coming from this set, and this is the function given to us. So let's check. First, fx equal to fy. So let's see. So this is x square is equal to y square, right? X square is equal to y square. So now see what is happening. I'm showing you. If x I choose as -1, so what is the value coming? It's coming +1. If x I choose as 1, I'm getting 1. If f I choose as -2, तो मुझे क्या मिल रहा है? 4. If f I choose as 2, तो क्या मिल रहा है? 4. That means I can tell that in the set A, if there is -1, 1, -2 and 2, and in the set B, if I choose -1, I'm getting 1 and 4. If I choose -1, I'm getting 1. If I choose +1, then also I'm getting 1. If I choose if I choose +1, I'm getting 1. If I choose -2, I'm getting 4. If I choose 2, I'm getting 4. तो देखिए, this is a many-to-one function. X का many value है, many x more than 1x having the same value of y. So it's a many-to-one function. Okay. Let's see. There is a function which has from x has to be chosen from the integer set, और y जो है वो integer set में से आना चाहिए. And it is given fx is equal to given mod x. So see, first of all I have to write the function properly. Fx, it will be x if x is greater than or equal to 0, and minus x if x is less than 0. mod का 2 वैल्यू होता है, right? That means, so see, if we choose positive values of x, मतलब 0 से लेके कोई भी positive values, if I choose all the positive values of x, I am getting the positive values, right? So my function will be taken as the positive values if x is chosen all the positive values. यहाँ पे if x is chosen the positive values, we are getting x all the positive values, and if x is chosen the negative values, we are getting x all negative values. That means what? For every positive value there is a positive value is coming, right? That means every positive number has its unique. For example, अगर मैं आपको दिखाऊं, if x is chosen as 1, I will get 1. If x is chosen as 2, I will get 2. In this way, if x is chosen as -1, I will get -1. If x is chosen as -2, I will get -2. That means for every x, you are having a single value. तो इसका मतलब है, clearly we can see that this is A, this is B. If I choose +1, I am getting +1. If I choose -1, I am getting -1. If I choose 0, I will get 0. If I choose -2, I will get -2. If I choose -3, I will get -3. In this way it continues. That means this is how they are linked. So it is a one-to-one function. It is a one-to-one function basically, and not a many-to-one function. It is a one-to-one function. Clear? Let's move on to the next one. Show that the function this is defined by fx equal to x square plus x is a many-to-one function. Let's try. So what we will do, we are choosing two different values from the set A such that x is not equal to y, and let's now check fx. fx क्या आ रहा है? x square plus x. fy क्या आ रहा है? y square plus y. Okay, so let us now see by making fx is equal to fy. So x square plus x, y square plus y, तो क्या लिख सकते हैं? x square minus y square plus x minus y is 0, और x minus y, x plus y, x minus y is 0. If I take x minus y common, then it is x plus y, this is plus 1. That means x minus y is equal to 0, or x is equal to y, and x is equal to minus y minus 1 means for a single x there are two values. For a single x there are two values. एक है y और एक है minus y minus 1. So it is a one to many function. It is not a many to one function. आपका देखिए y for let me write it like this. 1 minute, sorry, let me write it like this. If I write it, y is equal to, suppose I put x as 1, तो y कितना आ रहा है 1. ओके, एंड नाउ सपोज आई पुट x as 1, suppose I put x as 1, तो what is y coming? -1 -1 2. दैट मीन्स एक x के लिए 2 y आ रहा है, एक x के लिए 2 y आ रहा है, एक है 1 और एक है 2. सो इट्स अ 1 to many function. It's a 1 to many function, right? It is a 1 to many function. So next let us see, that is we have OnTwo function. Now let us see OnTwo function. What is OnTwo function or surjection? OnTwo function or surjection. What is OnTwo function or surjection? देखिए, suppose you choose a set. Suppose you choose a set A and there is a set B. If every element of the B has its pre-image, every element of B has its image in A, every element is the image of somebody in B, every element of B is the image of some element of A, it is an OnTwo function और surjection. ठीक है, एंड इनटू फंक्शन किसको बोलेंगे? Suppose these are the elements. Suppose every element of B is somebody's image in A, लेकिन इसका कोई इमेज नहीं है, इसका कोई भी इमेज नहीं है, इसका कोई इमेज नहीं है. दिस इज नॉट द इमेज ऑफ एनी एलिमेंट, दिस इज नॉट द इमेज ऑफ एनी एलिमेंट. ओके, एवरी एलिमेंट ऑफ, मतलब ऑल एलिमेंट्स ऑफ बी आर इमेजेस ऑफ द एलिमेंट्स ऑफ ए, बट एक एलिमेंट बी का छूट जाता है, सो दैट इज कॉल्ड इनटू फंक्शन, दैट इज कॉल्ड इनटू फंक्शन. और ये है OnTwo फंक्शन, ये है OnTwo फंक्शन. मीन्स एवरी एलिमेंट ऑफ बी इज द इमेज ऑफ सम एलिमेंट ऑफ ए. तो अगर बी के सारे एलिमेंट्स ए के किसी न किसी एलिमेंट्स के इमेज हैं, तो दैट इज OnTwo. और अगर बी का एक एलिमेंट छूट जाता है मिनिमम, जो किसी का इमेज नहीं है ए में, तो दैट इज एन इनटू फंक्शन. फॉर एग्जाम्पल, लेट अस शो दिस. So this is the set A given and B given. Okay. Now the function is given fx equal to x square. Show that it is an OnTwo function. तो देखिए, if I choose x as -1, तो हमको +1 मिल रहा है. If I choose +1, तो हमको क्या मिल रहा है? It is +1. If I choose -2, I am getting 4, and if I choose +2, I am getting 4. तो देखिए क्या मिल रहा है. That means if I would have chosen, this is a set A, -1 1 -2 2, and B was having 1 and 4. -1 का 1 मिला था, -1 का भी 1 मिला था, -2 का 4 and 2 का 4. So see, every element of B is somebody's image in A. Every element of B is somebody's image in A. So it is an OnTwo function. It is an OnTwo function. Every element of B is somebody's image in A. So it is an OnTwo function. Clear? Let's see more. Let's see some more. 1 minute. Okay. So now let's see the next example. The next example is, this is a function. We have to choose our x from natural numbers, and we will get y from the natural numbers. They are telling it is not an OnTwo function. Fx equal to 2x is not an OnTwo function. So let's see. If I choose x as 1, I'm getting 2. If I choose x as 2, I'm getting 4. If I choose x as 3, I'm getting 6. If I choose x as 4, I'm getting 8. तो देखिए, what is happening is, this is the natural number set A, and here I've got 1, 2, 3, 4 dot natural number, and this is set B. So here it is also natural number 1, 2, 3, 4, 5 dot. Okay, so when I am choosing 1, I am getting 2. When I am choosing 2, I am getting 4. When I am choosing 3, I am getting 6. To watch one, this continues. So watch one thing. कि हम natural set, natural numbers, every element natural number we are choosing, but this is left. इसका image नहीं है. In this way, that means all the odd numbers. So basically you can see that all odd numbers which are coming here do not have any image in A. That means we have to leave out all the odd numbers. So since all the odd numbers are left out, so we can tell each and every element of B is not having the image in A. So it is not an OnTwo. ये OnTwo function नहीं है. Let us discuss the next one. Surjectivity. As I told you, surjectivity. What is surjectivity? Right? So here we will be discussing what is this OnTwo function. Surjectivity or OnTwo function. Okay. So fx is equal to x cube. So let's check. Fx is equal to x cube, and I have to choose numbers from real numbers to real numbers. Okay, we have to choose x cube plus 2. So let's see. For every element, see, for every x belongs to the real number. For every x belongs to the real number. ठीक है? So we can choose any real number. Now see, y is equal to x cube plus 2. तो x कितना आएगा? y minus 2 to the power 1 by 3. To the power 1 by 3. That means whatever y we take the real number, x should come a real number. That means for every x belongs to R, y should belongs to R. That means in the set B, every element has an image in the set A. Every element in the set B has an image in the set A. Right? मैं y को कोई भी real number choose कर लूँ and put it here, I will get x as different real numbers. That means मैं किसी को छोड़ नहीं सकता, देयर इज नो कंडीशंस कमिंग कि मैं किसी पर्टिकुलर नंबर को ले नहीं सकता, राइट. सो एवरी वाई in the set B can be chosen. That means it is a OnTwo function. It is an OnTwo function, and so it is surjective. It is surjective. Okay. Second, let's see the next one. Fx is equal to x square plus 2, and it is also real to real. That means if I choose for every x belongs to real number, है ना. So let us see that for every x belongs to real number, let us check x square plus 2. X will be what? Y minus 2 root y minus 2 root. But we know inside the root, see, if y is taken less than 2, है ना, तो this is not possible. If y is taken less than 2, x does not belong to a real number, क्योंकि रूट के अंदर नेगेटिव वैल्यू नहीं आ सकता है. रूट के अंदर if y is taken less than 2, रूट के अंदर नेगेटिव वैल्यू नहीं आ सकता है. दैट मीन्स वी कैनॉट टेक ऑल वैल्यूज ऑफ y. वी कैनॉट टेक ऑल वैल्यूज ऑफ y. वी कैनॉट टेक ऑल वैल्यूज ऑफ y. दैट मीन्स कुछ वैल्यूज ऑफ y दे आर गेटिंग unchosen. That means from the set B which contains the y, this is set A which contains the x. So there are real numbers. ये real numbers हैं, real numbers. So here we cannot take numbers which are less than 2. Which cannot take number. That means there will be certain numbers. So less than 2 numbers will be left out. Less than 2, that means only more than 2 numbers are allowed. 2 के बाद से कोई भी number allowed है. So that means all numbers are not chosen. All numbers are not chosen. All numbers are not chosen. So कोई नंबर रह जा रहा है. That means it is not an OnTwo function. It is an INTO function. Not OnTwo function. It is not an OnTwo. Next, third one. F z to z, integer to integer, fx equal to 3x plus 2. So let's check fx equal to 3x plus 2. Fx is equal to 3x plus 2. They are telling that you have to choose x from the integer and you should get y from the integer. So let's see. Y equal to 3x plus 2, x equal to y minus 2 by 3. So here you see that if I choose y less than 2, if I choose y, if y is less than 2, x does not belong to integer. तो वो integers में नहीं आएंगे. That means I cannot choose y less than 2. I cannot choose y less than 2. That means less than 2 numbers of y will be left out. Less than 2 numbers of y will be left out. Okay, so that's why I can tell that this is not OnTwo function, क्योंकि कुछ values in the set B has to be left out. कौन से left out? Less than y. Less than y cannot be chosen. I can choose y only from 2 and above, 2 to infinity. And more importantly, I cannot choose because they are giving me fractions. So all the fractions, suppose those which give you fractions has to be left out. those which give you fractions. For example, I cannot choose, let me tell you, show you this. Suppose if I choose if y is equal to 3, x is coming 1 by 3, and which does not belong to z. So that means there will be many values of y which will be left out. So ये onto नहीं है, right? Next, let us see. Show that the function n to n f1 equal to f2 equal to 1. That means if I choose 1, if I choose 2, my answer will be 1. For 1 it is 1, for 2 it is 1. Acha. Up next, let us see. This is the set A, set B. What is set A? Set A is a natural number, set B is a natural number, and let us see the function. Fx is given as x minus 1 greater than or equal to 2. For 2 it is 1. Okay, so let's see. If it is 3, I am getting 3 minus 1, which is 2. If it is 4, I am getting 4 minus 1, which is 3. Right? That means y is equal to x minus 1. So x is equal to y plus 1. Y plus 1. That means, see, whatever values of natural number you choose, you will get one more than that. You will get one more than that. Right? Whatever value you get, you will get one more than that. So that's why, see, we chose x equal to 1, we got 1. We chose x equal to 2, we got 1. Right? We chose x equal to 3, we got 2. We chose x equal to 4, we got 3. We chose x equal to 5, we'll get 4. That means all the numbers in the set B is chosen. So all the numbers in the set B is chosen. That means there is no element in the set B left out. So it is an onto function. Clear? It is an onto function. Onto कब होता है? When set B has all the elements as the image of somebody in the X. And it is not one-to-one function. Why? Why it is not one-to-one function? It is a many-to-one function. यहाँ पे आप देख रहे हैं. Because if I choose 1, I am getting 1. If I choose 2, I am getting 1. So it is a many-to-one function. It is a many-to-one. It is many-to-one onto function. It is a many-to-one onto function. Clear? Next, let us see about the signum function. So we'll choose x from the real set and get y from the real set. They are telling show that the signum function is neither one-to-one nor onto. So let's check. This is the signum function. Signum function क्या होता है? If x is greater than 0, you will take it as 1. If x is equal to 0, you will take it as 0. If x is less than 0, you will take it as minus 1. इसका मतलब क्या है? Means for every x belongs to, for every x, so for every x belongs to, if I write it here, that if I take for every x which is belonging to a real number, I am seeing मेरे y का सॉल्यूशन क्या आ रहा है, y का सॉल्यूशन आ रहा है आइदर इट इज 1 0 और -1, है ना. सो फॉर दैट मीन्स व्हाट, दैट मीन्स फॉर एवरी x, that means whatever x I choose, my answer for every positive, for all positive, for agar x are all positive numbers, that means my answer is coming only 1, isn't it? For x all negative, my answer is coming -1, and for x which is giving you 0, my answer is coming 0. So that means it is a many-to-one function. It is a many-to-one function, right? Next is ये OnTwo function नहीं है, because you see here the y values are all real numbers, but यहाँ तो हमने खाली 3 ही real number लिए हैं. We have taken all real numbers. That means there are other real numbers from the set B. We have only taken 1 plus 1 0 and -1. That means there are all other real numbers यहाँ पे हैं which has not been taken. Okay, so this is it is not an OnTwo function, क्योंकि OnTwo function में every element of B should be the image of some element of A. A यहाँ पे क्या है, all real numbers है. A is a set of real numbers. Clear? Next friends, let's come to the thing bijection. What is a bijection? If it is a injection, that is 1-to-1 and OnTwo function and OnTwo, it is a 1-to-1 and OnTwo function, it is a bijection. अगर आपने इसको 1-to-1 प्रूव किया and OnTwo प्रूव किया तो this is a bijection. For let us see this. Okay, so here we are choosing rational numbers. Q, what is Q? Q is a rational number. Number. Okay, so rational to rational, that means suppose √2 is irrational, √3 is irrational, this is irrational number, ये rational नहीं है. That means whose square root cannot be done will not be chosen, either for the x part, and I cannot get an irrational number for the y part. मुझे irrational मिल भी नहीं सकता है and मुझे rational I will not choose. So let us see. fx is equal to 2x minus 3. So for 1-to-1, what did I tell you? कि for every x and y, okay, belongs to the rational number. So let's see. I have to show that I have to take fx equal to fy and prove that x is coming equal to y. So let's see. fx equal to fy क्या आ रहा है? So it is 2x minus 3 is equal to 2y minus 3. So minus 3 cuts. So we are getting x is equal to y. That means if I choose x, that means if I whatever rational number I will take, I will get a rational number. That means it is a 1-to-1 function. Clear? ये तो हो गया. Next we have to prove that it is an OnTwo function. So for the function fx is equal to 2x minus 3, y is equal to 2x minus 3, x is equal to y plus 3 by 2. So for this part you see, अगर ये मेरा रैशनल नंबर है, तो दैट मीन्स दिस शुड बी माई रैशनल नंबर, दिस शुड ऑल्सो बी माई रैशनल नंबर, दिस शुड ऑल्सो बी माई रैशनल नंबर, दिस शुड बी माई रैशनल नंबर. ओके, तो अगर रैशनल है, that means my y should be a rational number, my y should also be a rational number. क्योंकि please see here, y plus 3 रैशनल के साथ कोई भी आप कुछ ऐड करें तो क्या होगा, रैशनल होगा. सो न्यूमरेटर इज रैशनल. अगेन y plus 3/2 रैशनल को आप किसी से डिवाइड करेंगे तो वो क्या रहेगा, इट इज अ रैशनल नंबर. दैट मीन्स दिस होल थिंग इज अ रैशनल. तो अगर x रैशनल है तो दिस पार्ट इज ऑल्सो रैशनल, मीन्स y इज ऑल्सो रैशनल. y is also rational. That means every rational number from the set B is chosen. Every rational number from the set B is the image of some rational number from the set A. From the set A, every rational number from set B is the image of some rational number from the set A. Okay, so this is an OnTwo function. So ये OnTwo फंक्शन भी है. एंड इफ इट इज एन OnTwo तो मैंने बाइजेक्शन क्या बताया था, इट शुड बी 1-to-1 फंक्शन एंड इट शुड बी एन OnTwo फंक्शन. इट शुड बी एन OnTwo फंक्शन. ये दोनों होना चाहिए. क्लियर? चलिए नेक्स्ट, लेट्स सी दिस. Show that the function f r to r which is defined by this, so here, sorry, to show that the function which is defined by this is a bijection. Okay, so let's see one by one. Let's see it one by one. First of all, we have to choose the x from the real number. It is given that we have to choose the x from the real number and we have to get y which is in the real number. Okay, so first let us check for 1-to-1 function. 1-to-1, तो 1-to-1 में क्या करेंगे, fx is equal to fy and we have to prove x is equal to y. So this is 3x cube plus 5 is equal to 3y cube plus 5. This goes, so x cube is coming equal to y cube, which is x is equal to y. That means this proves it is a 1-to-1 function. Okay, now let us show that it is an OnTwo function. इसको OnTwo दिखाना है. OnTwo function. So first of all, this is our function 3x cube plus 5. I can write y is equal to 3x cube plus 5. तो x क्या होगा, y minus 5 by 3 to the power 1/3. Right? Now, as I told you that if x is a real number, if x belongs to a real number, that means here y definitely can take any real values. Y can take any real values. अगर x belongs to real number है तो y can take any real values. Yes, there is no limitation for that because real number is any number, real number. So if x is any real number, इसका मतलब y भी any real number हो सकता है, right? That means all the values of the set B which belongs to, from where we have to choose your y, actually it's a real number, हमको यहाँ से y choose करना होगा, and this is your set A which is again a real number, real set. I have to choose x. That means for every x real number there is a y which is a real number, right? For every x real number there is a y which is a real number. मतलब किसी नंबर को आप छोड़ नहीं सकते, किसी नंबर को आप छोड़ नहीं सकते, right? So that means it is a OnTwo function. It's a OnTwo function, and if it is a 1-to-1 and OnTwo function, इसका मतलब क्या है? It is bijection. It is bijection. Clear? Next, let us see. So they are telling that a equal to x belongs to real number from -1 to 1. मतलब a will be from -1 to 1 and b is also from -1 to 1. So they are telling fx is equal to x mod x. अब इसका देखिए दो पार्ट हो सकता है. It can be x square if x greater than 0. It can be 0 if x is equal to 0, and it can be minus x square if x is less than 0. ये मेरा फंक्शन है, right? So let us now take it from here. They are telling show that it is a bijection. Show that it is a bijection. तो सबसे पहले क्या करते हैं? इसको 1-to-1 प्रूफ करते हैं. 1-to-1 फंक्शन. पहले इसको 1-to-1 प्रूफ करते हैं. ओके, दैट मीन्स सी फॉर एवरी x greater than 0, for every x greater than 0, whatever we take, we are getting y fx. So let's see here, let us see. So there will 3 cases will come. Case 1, x greater than 0. तो fx is equal to x square, इसको लेके करेंगे. So fx is equal to fy. That means x square is equal to y square, right? That means for all x greater than 0, for all x greater than 0, okay, what we will take, we are seeing that fx equal to x square. ये मेरा फंक्शन है. That means I can take x is coming equal to plus minus y, plus minus y, right? So here for every x we are getting a plus minus y. First let me do one thing. So see here, if I write, 1 minute. So fx is coming equal to xy. So that means I can write x square equal to y square. That means x is coming plus and minus y, plus and minus y. That means what? For every different, that means for every different, it's a 1-to-1. It's a 1-to-1 function. So watch here. That means what I can do here, I can show it to here, that if I choose for this part and this part, I'm showing you. if x equal to suppose half, y is equal to 1 by 4. Okay, if x is equal to minus half, y is equal to minus 1 by 4, right? That means from here I can see for every different x there is a different y. For every different x there is a different y. So I can say it is a one-to-one function. It is a one-to-one function. For every different x there is a different y. Okay, so that means all the values of x from minus 1 up to 0, if I choose, that means I am getting y whose value is also coming from minus 1 to 0. Then if I choose x equal to 0, y equal to 0. Then if I choose x belongs to from 0 to 1, then y is also coming values which fall between 0 to 1. That means it is a one-to-one function. Clear? Now let us see OnTwo function. OnTwo function. So first of all, y is equal to x square. That means x is equal to root over y. X is equal to root over y. Similarly, y is equal to minus x square. So minus y is equal to x square. So x is equal to root over minus y, which is not possible. Which is not, that means I cannot choose negative. Means from here it's possible. See, we are seeing here. First of all, see here. For any positive values of x are accepted because I will get y positive. For any positive values of x accepted because y is positive, right? Acha. If x is 0, then also it's possible. If x is 0, y will be 0, so then also it's possible. Now from here we see that if I choose y, y is equal to minus of x square, correct? So from here we can see that if I choose x as negative values, okay, so the value of y is coming how much? The value of y is coming negative. That means it is a 1 to, that means all values of x can be chosen here. All values of x can be chosen here, right? So if y is coming negative values, so negative and negative positive values, if y comes negative values, see x is coming to positive values which is accepted. Inside the root it's coming positive values which is accepted. That means for every different x there is a different y. So it is a OnTwo function. It's a OnTwo function. All the values of y are chosen. All the values of y are chosen. The second set values, all the values of y, here y means b, are chosen, and we can get all the values of x. That means the set A. So it is an OnTwo function. So if it is an OnTwo function, one-to-one function, and if it is an OnTwo function, it is a bijection. It is a bijection. Clear? Let's see, friends, here. So here we are seeing that there is a function. Here we are seeing that there is a function fn to n, fx equal to 2x. We have to show that it is an one-to-one function as well as it is not an OnTwo function. Not an OnTwo. So let's see. One-to-one function. Okay. Fx is given 2x. So clearly it is being seen that for this is the natural set 1 2 3 4 5. For every value we are getting how much? First it is coming 1 2 3 4 5 6 7 8 and dot dot dot, it continues. So for 1 we are getting 2, for 2 we are getting 4, for 4 we are getting 6, for 5 for 3 we are getting 6, for 3 we are getting 6, and for 3 we are getting 6, for 4 we are getting 8. That means what? It is a 1-to-1 function. It is a 1-to-1 function, right? And fx is equal to fy. So 2x is equal to 2y. So x is coming equal to y, which proves that it is a 1-to-1 function. For every x there is a y. Now come to OnTwo function. Fx is equal to 2x, y is equal to 2x, x is equal to y by 2. That means what? We can take y only those values which are even, because other values will give a fraction, and that then x will not be a natural number. Only y belongs to even numbers, even natural numbers. X belongs to natural numbers. That means all odd numbers are left out. All odd numbers are left out. That means in the B, suppose it is 1 2 3 4 5 6, continue. So here in the set B we will be leaving out all the odd numbers. That means this will be left out, this will be left out, this will be left out, this will be left out. That means if these are left out, that means we are getting many numbers who do not have images. They don't have images in the set A. That means it is not an OnTwo function. So it is not OnTwo function. Clear? It is not an OnTwo function. Next, see the next one. Show that the function f R2R given by fx equal to x square is neither 1-to-1 nor OnTwo. Okay, so let's see. Fx is equal to x square. That means we have to show that if I take fx equal to fy, we have to get x equal to y. So x square is equal to y square. That means I can write x is equal to plus minus y. So it is not a unique solution. For every x there is either plus y or it is minus y. That means there are two solutions. It's one to many. That means it is not 1-to-1 function. It is not a 1-to-1 function. Clear? Next, for OnTwo function, fx is equal to x square, y is equal to x square, x is equal to plus minus root y, plus minus root y. So watch here, only the positive values of y, only y greater than or equal to 0 values are accepted. Okay, that means y less than 0 do not have any image in X Therefore it is not OnTwo. It is not an OnTwo. Okay, and it is neither an one-to-one function. It is neither one-to-one nor OnTwo. Next, they are telling show that it is a bijection. Okay, so first of all, for bijection, first I have to show it is a one-to-one function. So let us take fx is equal to fy, x cube is equal to y cube. That means x is equal to y. So if x is equal to y, it is a one-to-one function. Clear? That means for every different value of y, it is a different value of x. Or for every value, for every x belongs to real number, y belongs to a real number. That means it is a one-to-one function. Next, OnTwo function. Fx is equal to x cube, y is equal to x cube. Therefore x is equal to y to the power 1 by 3, y to the power 1 by 3, right? That means for every y belongs to a real number, x will belong to a real number. That means all values of the set B has an image. So it is an OnTwo function. So if it is an OnTwo function, it is a bijection. It is a bijection function. Clear? Next, let us see. Show that the greatest integer function is neither one-to-one nor OnTwo. Okay, so let's see. One-to-one. Fx is equal to fy. That means the greatest integer of x, the greatest integer is of this is y. So from here we can tell, from here the values of x and y will not be the same, right? For example, see here, for example, if x is chosen as 2.13, the greatest integer will be what? 2. And here, suppose I take 2.15, it is also 2. It is also 2. So watch here one thing, that means in this function only we can choose, see, this is f is real to real, real to real. That means what happens is for every x we choose, like from one point, like from 2.0 up to 2.99, if I find the greatest integer of x, the answer is how much? The answer will be how much? It is only 2. It is only 2. Right? The greatest integer function will be 2. That means this is the value of y. That means for so many values of x, the answer of fx, which is greatest integer, which is y, is coming only 2. That means it is a many-to-one function. It is a many-to-one function. That means for so many values of x from 2 to 2.99, for example, if I choose, the greatest integer of these values will come only 2. That means y has only one value, 2. For all so many values of x, there is only one value of y, which is 2. So it's a many-to-one function. So it is not a one-to-one function. Next, let us see, check the OnTwo function. fx equal to mod x. That means for all values of, for all x belongs to the real number, y belongs to the integer number. Y is always integer. That means the decimal numbers are missing, isn't it? Y is only integer numbers, only integer. That means decimals, values of y do not have an image, do not have an image. Okay, that means it is not OnTwo function. It is not an OnTwo function. Clear? Next, let us see its mod x. So fx equal to x for x greater than equal to 0 and minus x for x less than 0. Okay, so we have to tell it is neither one-to-one nor OnTwo. So watch here. Whatever values of x for every x belongs to the negative number. Okay, like if I take from here, like x belongs to minus infinity to 0, y will belong to the positive values, the real positive values. Okay, that means for whatever negative values we take, we are getting all the positive values. For every x belongs to 0 to infinity, y for every positive x, sorry, it is negative, 1 minute, this will be negative for all whatever value of x. If I choose as negative, if I choose x as negative, y I will get all positive values, correct? And if I choose x as all positive values, y again I am getting positive values. That means the negative values of x, thus y belongs to negative values do not have any image. Okay, therefore it is not one-to-one. Mod x is not one-to-one. Clear? Next, come to OnTwo function. So in the OnTwo function, we can easily see that the negative values of the negative values y belongs to the negative r do not have any image. For any values of x. Okay, so it is not an onto. So your onto function, this is not an onto function. Clear? So this is not an onto function. Next, let us see. Show that the function this real to real ax plus b, where a and b belongs to the real numbers, a not 0, is a bijection. So let's see. First is an one-to-one function. Fx fy so b and b cuts, a and a will cut, so x, therefore x is equal to y, right? X is equal to y. That means whatever x you choose, you get the same y. Whatever x you choose, you get the same y. Therefore, this is a one-to-one function. One-to-one function. Clear? Next, onto function. Fx is ax plus b, y equal to ax plus b, therefore x is equal to y minus b by a. Therefore, for every y belongs to real number, x will always be from the real number. That means all the values of y have an image. All the values of y has an image. So it is an onto function. And if it is an onto function and one-to-one function, so it is a bijection. Clear? Next, let us see. Fx is neither one-to-one nor onto. So we all know, please see that cos x, the values of cos x will always lie between -1 and +1. The values of cos x will always lie between -1 and +1. Okay. So in this case, we are seeing that if I take fx as cos x, if I take fx as cos x, so I can write that for x belongs to R, y will always belong to -1 and 1. That means it is a many-to-one function. It's a many-to-one function, so it's not one-to-one function. Okay. For whatever value of x you choose, the value of cos x, that means y, will always be from -1 to 1. Next, onto, that means fx equal to cos x, fx is equal to cos x. So we can see that since the values of y, since y belongs to -1 and 1, that means outside only these values have a range, only these values have an image, only y belongs to -1 and 1 have an image in x belongs to real number, that means it is not an OnTwo function. Okay, so it's not an OnTwo function. There are many values of y, real numbers, which are not having an image. Only these values from -1 to 1 have an image. Other values do not have an image. Okay, so it is a 1-to-1 function. Next, see, we have to choose a, all real values but not 2. We have to get y, this is x and this is the y part. So y, they are telling you can get all real values except 1. So they are telling show that fx is a bijective function. So let's see. One-to-one function. Fx is equal to fy. Let's cross multiply. So from here we can see that it is coming minus 2x plus x. That means minus x minus y. Therefore x is coming equal to y. So it is an 1-to-1 function. It is a 1-to-1 function. Clear? Next, let us check about the OnTwo function. Y should not be 1. I cannot take y as 1. I cannot take y as 1. Okay. So what is happening? See here. I cannot take y as 1. If I take y as 1, so see what. So let us see. Yes, we cannot take y as 1. It is clear that the values of y cannot be taken as 1. Right? And otherwise we can take any values. Because they have given that b, which is y, r minus 1. Yes, that means we can take any other values except 1. So definitely that means for all y belongs to r minus 1 have image for all x belongs to r minus 2. That means it is a OnTwo function. It is an OnTwo function. And since it is an OnTwo function and 1-to-1 function, so it is a bijective function. Clear? Let's look into the thing. So x we have to choose from real numbers, and y, how do we get? See, real to this. That means from -1 to 1. So let's see. They're telling that prove this function, this is the function, prove this function is 1-to-1 OnTwo function. That means we have to prove that it is a bijective function. 1-to-1 and OnTwo. We have to prove that it is a bijective function. So let's see. 1-to-1 function. First of all, the function will have, let us write the function. It will be x by 1 plus x for x greater than equal to 0 and x by 1 minus x for x less than 0. Okay, so we have to choose now one by one. That means first let us choose fx equal to x by 1 plus x. So fx equal to fy so x plus xy is equal to y plus xy. That means x equal to y. So it is a 1-to function for 1-to-1 function for this set. And now let's check 1-to-1 for this. Fx equal to x by 1 minus x. So x is coming equal to y. That means for both the functions x is coming equal to y, which is, it is a 1-to-1 function. Now let's check about the OnTwo function. There are two functions, fx equal to 1 plus x y cannot be 1. Okay, so yes, we have taken, we cannot take y as 1, we cannot take y as 1, otherwise we can take any values. We cannot take y as 1, right? Otherwise we can take any values of y. Okay, so first of all, means we can take values of y from -1 to from 0 except 1. Any values of x y we can choose. So we can choose y from -1 to 1, right? Therefore x will be coming as a real number. Clear? Now let us check for this function. X by 1 minus x. That means y cannot be chosen as -1, else I can choose for any value of y. Okay, therefore for y belongs to -1 to 1, x belongs to real number, I can choose. That means it is an OnTwo function also, so it is a bijection. It is a 1-to-1 and both OnTwo function. Next we have to check whether this is a bijection or not, so that it is a bijection. show that it is a bijection. So let's check. First let us check. We have to take x from the real and get y from the real. One-to-one function, let us check it. So we are getting x is equal to y. We are getting x is equal to y. That means it is a one-to-one function. We are getting x is equal to y. Okay. So for whatever values of x we are getting x is equal to y, and so for whatever values of x we get, and for this solution, for this, see, this part we know x has to be taken, x belongs to a real value. Real values. We will get x equal to y from here, which proves that it is a one-to-one function. Which proves that it is a one-to-one function. Okay. And here, whatever values of x we take, we will get y as a real value also. So x belongs to real number and y also belongs to the real number. And since we are getting x equal to y, it is a one-to-one function. Next, let us see OnTwo function. See, it is a cubic function. It is a basically it is a cubic function. That means x will have real roots. Will have real roots for every y belongs to real number. For every y, whatever value of y we choose as a real number, x will be coming from the real value. Okay. So that means it is an OnTwo function. All the values of y are chosen. They will have image in x. All the values of y will have their images in x. Will have their images in x. Definitely all the values of y will have their images in x. So it is an OnTwo function. So since it is an OnTwo function and an one-to-one function, it is a bijection. Clear? Next, let's see this function. We have to choose from natural number to natural number. Two functions are there, x plus 1 by 2 if x is odd, and if x is even, we have to choose this equation. They are telling show that it is a many-to-one OnTwo function. Many-to-one, not one-to-one, many-to-one OnTwo function. So let's see. Both the equations I have to check. X equal to y we are getting, and then x equal to y we are getting here also. So see, if I choose x as odd numbers, in this case, if I choose x as odd numbers, so see, suppose x I choose as 1, so it is 1 plus 1 by 2, it is 1. If I choose x as odd numbers, okay, 3, so it's coming how much? 3 plus 1 by 2, it is 2. If I choose x as odd numbers, so I'm getting how much? 6 by 2, which is coming 3. That means for all odd numbers, x belongs to odd numbers, odd natural numbers, we are getting y belongs to the natural numbers. Okay, again see, in this one, if I choose x as even number, so fx equal to x by 2. Suppose x is taken as 2, so how much getting? 1. If x is taken as 4, I'm getting 2. If x is taken as 6, I'm getting as 3. That means again, for all x belongs to even numbers, y belongs to n. Okay, that means see, when x is chosen as 1 and x is chosen as 2, we are getting both the answers as 1. See here, when x is chosen as 1, we are getting y as 1. When x is chosen as 2, we are getting y as 1. So it's a many to one function. It's a many to one function. Clear? Next, we have to show that it is an OnTwo function. We have to show that it is an OnTwo function. So let's see. So fx, using this function, x plus 1 by 2, y equal to x plus 1 by 2, therefore x is coming 2y minus 1, right? That means whenever we choose y as 1, if I choose, if y equal to 1, x equal to 1, y equal to 2, x equal to 3, y equal to 3, x equal to 5. That means for all natural numbers, see, odd numbers are the images here. Okay, so we are choosing all the natural numbers in the set y. They are becoming the images of these numbers. Similarly, if I choose this fx equal to x by 2, y equal to x by 2, x equal to 2y, that means I can show if y equal to 1, x equal to 2, y equal to 2, x equal to 4, y equal to 3, x equal to 6. That means, see, these odd numbers of x, they have their images here. These are the images, and these even numbers, they have the images. Okay, that means everybody in the set y has an image in the set x, has an image in the set x. Everybody in the set y has an image in the set x. All natural numbers in the set y has an image in the set x. So it is a OnTwo function. So it is an OnTwo function, definitely. It is an OnTwo function. Clear? Next, let us see. So we are choosing f from 0 to pi by 2, and we will get y as real numbers. This is the values of x we have to choose. Fx equal to sin x, and g we have to choose again x value for g function. We have to choose x values from here and get y as real values, and gx equal to cos x. Show that f and g are 1 to 1, but f plus g is not 1 to 1. Okay. So first let us see f x, which is sin x. Okay. And we know sin x's values lies between -1 and +1. Lies between -1 and +1. Okay. So from here we can see that whatever values of x for x belongs to 0 to pi by 2, 0 to pi by 2, it's in the first quadrant, which is sin is positive. Sin is positive. That means the sin x will take values from the positive value, will take the positive values, that means 0 to 1. It will take the values 0 to 1. For all x belongs to 0 to pi by 2, sin x will take the positive values. Clear? For whatever values of x we choose, for whatever values of x we choose between 0 to pi by 2, all the values of sin x, that means y equal to all the values of sin x from 0 to 1 we will keep getting. Clear? That means it is a 1 to 1 function. Correct? So let us check by this method also. Fx equal to fy, sin x equal to sin y, sin cuts, x is equal to y. So it is a 1 to 1 function. Okay. Now let us check for gx, cos x. Again I tell you, cos x's value also lies between -1 to 1. So let us take gx equal to gy, cos x equal to cos y, cos will cut, x is equal to y, that means it is a 1 to 1 function. It's a 1 to 1 function. Clear? 1 to 1 function. If you can prove x is equal to y, it's a 1 to 1 function. Now f plus g, that means sin x plus cos x. So what I can do is, I can write like this. This is sin x cos pi by 4 plus cos x sin pi by 4 sin x plus pi by 4. So that means here also, see, whichever values of x we choose, between 0 to pi by 2, the y, which is f plus g function, is a positive value, right? That means if I take like this, f plus g, let us prove like this. Sine x plus pi by 4 is equal to root 2 sine y plus pi by 4, root 2 cuts, sine cuts, x plus pi by 4 is equal to y plus pi by 4, it cuts. That means we got x is equal to y. Right? So in this case, we are getting x is equal to y. One thing, let me first see. Y plus pi by 4. Let me see. Please wait a sec. I think here some mistake is there. I'll correct it. I'll correct this. Wait. So friends, let's see here. Let's do one thing. I think we have to prove that it is not a one-to-one function. So let's first do one thing. Let us try with this part. Let us try out with this part. Okay, so watch here. I think we can do it like this. F plus g x, which is equal to sin x plus cos x. So if I take 0, it's coming sin 0 degree plus cos 0 degree. Sin 0 degree is 0, this is 1, which is coming 1. Okay, and if I take f plus g pi by 2, it will be sin pi by 2 cos pi by 2. Sin pi by 2 is 1 and this is 0, which is coming 1. So see, for 0 and pi by 2, we are getting the same answer as 1. So it's many to 1. It's many to 1 and not 1 to 1. So it's not 1 to 1. Okay. So friends, with this we have completed the function. One part we have completed the function, and next part we will be dealing with the composite functions. So what I would suggest you, please watch this function part very carefully. This is the part 1. This is part 1 of the functions. After that I will be dealing with you part 2, composite functions. This is part 1. So please watch the part 1 functions very nicely, because part 2 functions, what I will come up with the part 2 functions, it will be composite function. Composite function. So before that you have to understand the functions part 1. Okay, so please go through the videos, go through the lecture very nicely, watch the numericals very carefully. Okay, please do try to do the numericals along with me, that will help you much more. So in that case, please functions, keep watching this, the full video, please watch the full video, otherwise you will not be able to understand. इसको पूरा देखिए, and my suggestion is that go through each and every numericals. Okay, you pause the video and then you see how it is being solved. You personally you also try on your own so that you get benefited. Okay, so please watch the part 2 of this, which is the composite function, that will again help you. It's a very important part of the functions. Okay, so once more I would like to request you, please like, share and subscribe Parijat Sir classes, so that I am making a some very good videos for you, so that you can watch these videos and you will be much more benefited in your board exams. ये पूरे board exams को देख के ही ये बनाया गया है, and I am discussing some important questions here so that this will be helpful to you how to attempt in the board exams. Functions के chapter को कैसे attempt करेंगे, right? So please keep watching. Till then, it's bye from my side, and again we'll meet you in the next video.